guys, a very happy morning to every one of you. And guys, now we are just going to start another new interesting subject that is called theory of machines. So this theory of machine I was learned from Praveen Kulkarni sir, one of the top designator, and it's like a how to say means he's like a Albert Einstein of the next theory of machines. So why I'm just telling, because I just literally learned so many good things from him, so many quality things in the subject point of view and in the life point of view. So literally I want to thank the Praveen Kulkarni sir, who is one of the best faculty of the entire mechanical engineering. So in this subject, it means in this entire video, we will just be going to cover the entire theory of machines. Okay. So without wasting time, let us get started. Okay. So theory of machines. So just theory of machine means just working of machines. That's it. Means you can see machines theory. Okay, how the machine has been working. Okay, suppose they may tell it is practical, or they may be telling it theoretical. So mostly we will be covering the theory of machines entirely in theory point of view, as well as after covering the theory point of view, we will be talking about the practicality. Okay, how the machines will work, how the each and kinematics will work like that. Okay, for them, just for a simple sake, how to say means. Suppose let us have an example that you are having an engine. Okay, you are having how much okay, let us consider BMW bike. Okay, or let us consider one of the top, it means like a elite bike, BMW bike. Okay, so you are having BMW 310 RR, or let us, oh no, you are traveling in BMW S100 RR. Okay, so this is one of the, wow, see the color and see, wow, it's literally giving me sparkles. Okay, you can see the S1000 RR. So in this thing you can see how much this engine will be. Okay, just 1 second. So you can see the engine capacity is 1000 cc and the average mileage is 16 km per liter, and it means they have 6 gears. Okay, and this gear ratio also we are just going to see about it. Okay, fuel tank is literally 16 liters. Okay, you can see each and everything was been given, but the main thing is this is 1000 cc engine. Okay, so for example 1000 cc engine delivers, it means 1000 kilojoules of energy per second. Let's just consider, because burning of fuel and everything. So does this 1000 kilojoule of energy is effectively used in rotation of the entire wheel? You just think it, guys. Does it leads to the rotation of the entire wheel? It means 1000 kilojoules. It means without wasting of 1% or 2% of energy, does this 1000 kilojoules goes and makes this rotation? Okay, suppose if make this rotation means just consider about the friction, how the friction will be, and how the connecting will be, how the bearing will be, and how what about the materials? It means rubber material, how much the friction will be, and as well as the heat loss will be, as well as while it means while we are just using the crankshaft and the connecting shaft, each and everything, how much losses will be there, how much effectively the loss will be. So what are the number of links? Okay, number of links, and how the transmission will be. So each and everything in this video we are just, in this entire lecture we are just going to cover each and everything. Okay, so are you ready to travel the theory of machines with BMW S1000 RR? Let us have a good ride. Okay, so the thing, it means you can see all machines follow certain laws, certain theory and laws. In this we are just going to see thermo, it means theory of machine, kinematics and dynamics. Okay, kinematics means just a motion. It means how the machine is working, how the capability and which and everything. You can see motion means about the position, velocity, acceleration, ensures functionality. Okay, ensures functionality, that's it. Okay, so force we don't consider. Suppose you can see I just got 1000 kilojoules of energy, so will, it means each and everything, the force we don't consider. Okay, suppose the force, the vibration, the stress, like that we won't consider. Suppose if we just get 1000 kilojoules, how we can just convert this into force? It means not force, not velocity. Okay, so suppose how to say means let us mention this piston is goes up and down. Okay, it has a velocity, it means down velocity is 10 meter per second, and up velocity also 10 meter per second. Okay, so this 10 meter per second, how we can just transfer to the, it means the wheel, so it can run effectively in 10 meter per second. So like that. Okay, I think so you can understand. So transmutation of velocity, transmutation of acceleration, each and everything we are just transmitting. Okay, we don't consider the force. So next is dynamics. Dynamics, you can see stress analysis. Okay, when exactly, it means when external load applied, we see also internal. So that's how material do not fail. Okay, stress analysis means, I think so you would have known about the strength of materials, the engineering mechanics, and the vibrations, the machine design. These are comes under the stress analysis. Okay, dynamics, force analysis. Okay, I think so you can understand. Kinematics not force, dynamics only force and static and moving part. So whenever it's static, it comes to structural analysis. Static means strength of materials, and the dynamics means you can see it's a moving part. Okay, kinetics. Okay, kinetics is just a moving part. Kinematics means it's not moving part. Okay, I think so. Can a system which is sustaining force under static condition, which may fail in S. Definitely, this is also one of the good things. Why? Because suppose if this pen will, it means this pen will work in the static condition good, but whenever I just, suppose you can see I'm just fixing it one point and I'm just continuously rotating like this, that it means you can see the vibration and the stress will be so much here. So when giving a repeated motion due to the dynamic, this means this pen will lead to failure. Okay, I think so you got the point. So next one is mechanism. Oh, mechanism. So it's like mechanism is just a basic definition. Okay, you can see mechanism, it is a combination of rigid body connected in such a manner that move related to each other in a definite motion. Okay, it means I think so you got the point. So for example, let me show you a thing. Links move robot. So I think so you are getting the point. See, it means this is also link. Suppose you can see this is a joint, this is link. Okay, you can see if this link moves, it also related to moving of this one. Okay, you can see it is a combination of rigid body connected in such a manner that move, it means relative motion to one another in a definite manner. Okay, suppose whenever we are just moving one sector, the other sector also independently moves. Okay, there is a dependent link also, there is an independent link also. Okay, I think you are getting the point. So once again I'll just tell, it is a combination of rigid bodies connected in such a manner that move relative to each other in a definite manner. Okay, I think so you're getting the point. So while I'm explaining, it means you will just go accordingly. Okay, suppose if this thing we just relate with the thermodynamics zeroth law, means what is how can this relate? Suppose you can see this is A, this is B. Okay, A and B body are in thermal equilibrium with each other. Okay, so B and C body are in thermal equilibrium with each other. So does A and C body will be thermal equilibrium? Yes, definitely, because A is 100 degrees Celsius. Okay, B is also 100 degrees Celsius. Then what will be the reaction of C? C also will be 100 degrees Celsius. So if B and C are thermally contact, then definitely A and C also will be thermally in equilibrium. Okay, so you can see when one body move, it means moves. When it is suppose connected, interconnected, the other body also tends to move. Okay, that's it. Okay, thanks for understood. Okay, so this is the rigid body. So again, this is a normal thing. Okay? So you can see, it means after a particular small deformation, the resistance will occur. So be without deformation, the resistance also will occur. Okay, rolling chair. For example, yes, this is the normal thing. For example, in the rolling chair, when we sit initially, it goes down. Okay, suppose I think so you would have tried, when you just sit in the rolling chair, it just goes down. Okay, and after it becomes stable, now we consider rigid. So each and every time in the entire theory of motion, we consider only the rigid bodies. Okay, I think so you got the point. So at the time of deformation, there will not be any kind of resistance. Okay, I think so you can understand. So for example, when you just pull any kind of cloths, it means suppose this is a hand, this is a cloth you just consider. When I am just pulling this cloth, you can see this easily tends to deform. So like this you can see, this is a cloth. So you can see it easily deforms. Okay, so after certain angle you can see we can't deform it. Okay, so until it becomes rigid, we need to give the force, and afterwards we will just consider it is kinematics. After that we don't consider the force and we'll just go accordingly. Okay, next one is constraint manner, definite predictable way. It means we don't know, we know the how it can just go upon. Okay, mechanism, you can see we simply see the motion only, not force. Okay, transfer, it means transfer, it's also transfer and transformation, both two things. Okay, transfer means you can see rotation motion input, and outside also will go in a rotation motion. Okay, so transformation means entirely different. Okay, rotation motion is been transferred to sliding motion. Okay, I think so got the point. So next one is machine. Machine is one of the important things that you just want to have it. Okay, it is a mechanism or collection of mechanism which uses input power to produce certain enough output power. Okay, so it means I think so got the point. Machine, it's like it's a mechanism or collection of mechanism which uses the input work. So it uses the input work and transfers into the output work. It means desired output work. It means desired useful work. Okay, that's it. So machine has no capacity to produce power. We need to give power. Yes, definitely. Machine, for machine we need to give power. For example, this engine. Okay, for example, you can see this engine, whether we give the input, It means whether we, yes, definitely we give the input. How? By you giving the petrol as well as the spark plug, each and everything, we are just giving it. Okay. So you can see machine has no capacity, it doesn't have the capacity to produce the work internally. Okay, so power equal to rate of doing work W divided by T. It means force into distance divided by time. Okay, mechanism only motion, no force and work and power. Okay, so only motion. Okay, so but machine means power. It means, yeah, we are just seeing the entire mechanism only, guys. So machine means power, force, work, each and everything is being considered. So what divided by time? Okay, power means machine means power, force, work, and each and everything we consider. In machine, I think so you can see this one. In machine, the motion is hidden. Okay, but every machine is a mechanism, yes, definitely. But every mechanism is need not to be a machine. Okay, that's it. Just one second. Now we are just quoting an eagle's a good point of view. Okay. So next one you can see engine. It means you can see in engine and machine. So I go in a bike, okay, definitely. But in a machine, it is just a cycle. It means I'm just going in a cycle. So you can see we give the input power to run the machine. So for example, we just pedal the, it means cycle. So that's only it's going. But whenever you just see about the engine, we give the work. No, we don't give the work. It means how the energy is getting by the internal energy. It means by the burning of fuel only we are just getting the energy. Okay, mechanism, you can see watch only motion, no work it gives. Okay, no useful work. Okay, I think so getting the point. So the, it means the spending of the energy should be done by us. Okay, in kind of machines and mechanism. Okay, so you can see when it means in the entire the theory of machines, guys, whenever we just shade it black means it is completely fixed. Okay, so you can see we here is the drawing kinematic diagram, we just enter. Okay, and fixed body in the theory of machines is called as frame. Okay, body is a machine but inside skeleton is a mechanism. Okay, I think you got the point. Our body is a machine but our inside skeleton is a mechanism. Okay, so next one you can see theory of machines, analysis and synthesis. Okay, in this two things, analysis means older model and exciting existing model. So it means for how to say, means we have the cycle, it means the steering wheel and the gears, each and everything we know. Suppose instead of creating it newly, we are just using the old existing model and we are just rapidly developing it, means enhancing it. That is called analysis. But synthesis means we are just developing a new thing. Okay, so instead of having a gear mechanism, we are just completely going to nuclear dependent or nuclear oriented energy, like that. Differently we are just going. That's it. Okay, it is synthesis. It means developing a new machine. So link. Oh wow, link. What is link? So you can see this one, the link. So each and you can see the blue, I think so you can see this one. The blue part is called as link, and here the red part, I think so you are able to see this one. The red part is called as joint. Okay, so you can see link, it is a rigid resistant body or assembly of bodies such that it is meant for transmitting motion and guiding other members. Okay, links are just usually used for transmitting motions as well as the for other members. Okay, guiding other members. Okay, so whenever we just interconnect the two links, it becomes a joint. Okay, so you can see link around, link can be have of any shape or size. Okay, so you can see this one. So this is the entire link. Okay, whenever we just interconnect two links, it becomes as a joint. Okay, so this portion is responsible for the motion. Okay, it is called as element. Okay, it means joint is also responsible for the motion of the element. The portion of the link which connects the other link is called as element or joints. Also we can just tell. Okay, I think you got the point. So element working, okay, working zone, and you can see link. In kinematics, we are interested in geometry of motion, whether motion is straight or circular. Okay, so you can see this the link, maybe we in the entire theory of vision we just represent a different way. Okay, so I think so you're getting the point. So like this only most of the link will be. Okay, so you can see binary link, tertiary, you can see 3 dots are there, tertiary link, and 4 dots are there, quaternary link. So practical example I just do. So you can see this also comes under the category of links only. Okay, okay, so this multi-point link like that it will be. Okay, That's it. So you can see pulley wheel and each and how it means moving each and everything how it means there. Okay, so you can see this is the basic thing. So you can see this is a link. Okay, this leads to, it means link can also transfer the other motion called transformation. You can see this is a sliding motion, so this sliding is being converted to the rotation. Okay, I think so, can understand. So where further what we are just using this link, the link is called as connecting rod. Wow. Okay, so just a basic thing only, no need to just confuse yourself. Okay, so generally this will be represented as like binary link, and you can see two dots means it's a binary link, and you can see the square. So link doesn't depends on shapes. Okay, link doesn't depends on shape. Okay, I think so you can understand. So next you can see link doesn't have the shapes there. If the link is above binary, it is called as higher order link. Okay, it means instead of having two links, it is having 3 or 4 links. It is called as higher order links. Okay, I think so. So you can see this one. So this is a singular link. It is roboticum. So this is, you can see 3 dots is bent. So that's why it is called as tertiary link. Okay, I think so you got the point. So you can see 3 binary links are connected by the pin joint. Okay, you can see while you are just separating, you can see 3 binary joints. Okay, the next one is quaternary link. Okay, so quaternary link is, we can see 4 dots. Okay, mostly binary link use, it is simplest. Definitely in most of the times we are only using the binary link because it is simple, only 2 is there. Okay, next is types of link. So types of link also a little bit types. You can see rigid link, flexible link, fluid link. Okay, so in rigid link you can see deformation are very negligible. Okay, rigid link. Okay, so connecting arm, crank and piston. And next one is flexible link. You can see belt, rope and chain. So these are comes under the flexible link. And next one is fluid link. Okay, I'll just explain. Okay, so you can see in just in flexible, it means flexible link. In tension it means tensile only. Okay, this leads to transfer of motion. Okay, for example, so okay, let us see. For example, this is like this. Okay, from this link to this link I need to transfer the motion. So what I'm just doing, I'm just interconnecting and I'm just pulling it. So while pulling it, it becomes a tension force. Okay, so you can see, suppose if I just pull the right hand like this, you can see the left hand also comes like this. Okay, if I just pull the left hand like this, the right hand also comes like this. Okay, so at the center portion it should be have tension. Okay, so tension, tensile only they will be transmitting a motion. Okay, that's it. So generally tension leads to rotation of the different pulleys. Suppose if there is compression means it can't rotate. Okay, one way test only, that's it. Okay, flexible link or link only is the tension, and it also cannot transfer. It means flexible link cannot transfer. It means it can transfer. It can also transfer. It can transfer torque also. Okay, but after a certain limit only. So next link you can see fluid link. Okay, fluid is only in a compression. Okay, this is, you can see this is simply incompressible fluid, and this fluid acts as a link and causes a motion. Okay, so it is called as fluid link. Okay, and next one is spring. So you can see spring, does it transmit motion? No, it just stores. Okay, so generally the spring doesn't comes under the category of theory of machines. Okay, so we can see in dynamics spring very much useful. Okay, in dynamics only. So now we are just saying kinematic. Okay, but here kinematics we don't use the spring. Okay, remove the spring, and here only the kinematic analysis. Okay, so you can see next one rigid is all direction. Okay, next one flexible link is only tension, fluid is only compression. So due to the compression you can see this is Pascal law. When we apply the force in one direction, it goes and transmits in the other direction. Okay, so next is kinematic joint. Okay, what motion respect to the other motion, the connection between the two links, element of one joint to the element of other joint, that's it. Okay, so you can see we are just having the interconnection between the two links, that is two elements joint. Okay, so it is called a joint. So there may be binary joint, tertiary joint, each and everything. Suppose if we just welded means it won't become a joint also. Okay, it will become as a single link. Okay, that's why the welding is also we need to see. Okay, so next one you can see this is binary joint. Okay, it means two links being connected, so it becomes as binary joint. Okay, but actually you can see now we just take 3 links and we just interconnect, so it becomes tertiary joint. Okay, I think you got the point. So suppose if we just took the 4 links and we just interconnect, it becomes a quaternary joint. Okay, okay, So you can see this is a quaternary joint. Whenever there are two, it means more than two joint, it is higher order joint. Okay, that's it. So next one is tertiary link. You can see this whole is considered as a link. Okay, it means this entire system is been considered as a link, but you can see it is a tertiary link. Okay. So if I just want to explain this, you can see this is tertiary link. Okay. So in this only one joint, only joint is that joint is called as tertiary joint. Okay, you can see one link, two link, three link. So it's been connected, so it is tertiary joint. Okay, joint at where, at what point they are meeting, how many are meeting, we should see. Okay, that's it. Next one is frame. Frame is generally fixed link. Okay. So you can see drafter one we fix and we move and draw the diagram. Suppose I think so, we can see about the drafter. So all these things moves with respect to the fixed link. Okay. So in the entire theory of machines, we need to fix one side. Okay, fixing of one side. Okay. So kinematics where you can see pair simply means couple. So the connection between two links that permits relative motion. This is called as kinematic pair. Okay. The connection the connection between two links. Okay. We have to just connect the two links and there should be a motion. So that is called as kinematic pair. Okay. The connection between two links that permits relative motion. That's it. Okay. This is called as tertiary. So at pair we only take two things. Okay. Only two links we check and which has the relative motion. Okay. That's it. I think so you got the point. Okay. I think so you're getting the point. So the next thing we will be seeing the classification of kinematic pair. Okay. So what is pair? I just told to you. So there should be a relative motion between the two links. Okay. Whenever there is a relative motion between the two links, it is called as pair. Okay. So in this pair also there are three types. Okay. One is type of contact, relative motion, and as well as the types of closure. Okay. So type of contact means how it will be. So types of contact. So in the type of contact there are literally two types. It means type of contact itself. So one is low air pair, next one is higher pair. Okay. When two links are connected between area and surface, okay, area and surface, it is called as low air pair. Okay. Suppose you can see this my hand is entirely placed on this paper. So it is which pair? Low air pair. Okay. Suppose instead my finger is being placed on like this. Okay. You can see only one point is there. Okay. This is called as higher pair. So whenever an area means you can see the surface area it covers. Okay. The point is this higher pair. That's it. Okay. So both of the things comes under the category of, it means contact pair. Okay. That's it. So you can see higher pair is between the line or point. Okay. For example, you can see I am just placing this paper here, means you can see it will definitely form a line. Okay. Because you can see the surface, it is curved surface, due to that it will be a line. Okay. Higher pair between line and point. Okay. So lower pair is area and surface. Okay. So you can see this is area contact, point contact, and line contact. Okay. So you can see when it means in generally the higher pair, you can see load applied on at a point, stress at the point is very much high. So it is called as higher pair. Okay. In higher pair the stress is so much higher and high concentration stress will be. Okay. But in the lower pair, low concentrating stress will be. That's it. Okay. I think so you got the point. So whenever it means a lower pair, whenever there is a surface contact, the point will be same, give the same shape. Okay. You can see generally in the lower pair it will be giving us same shapes. Okay. You can see two links up and down, nail cutter. Nail cutter also I think it comes under lower pair. So we study inversion of the lower pair only, not, it means our most of the theory of machine we will be studying only the lower pair. Okay. Not about the higher pair. Okay. I think so you got the point. So lower pair are suitable for inversions. Okay. Lower pair are suitable for inversion. Inversion I will just tell. Okay. Suppose you can say this is the link, this is the link. I am just interconnecting the links like this. Okay. So after that I will just make the one link fixed and I will just see the motion. Or I will just fix this link and I will see the motion. This is called as inversion. Inversion means just fixing of one link and the movement of other thing we will just see. Okay. So you can see lower pair we fix one and rotate other. So and vice versa, and same will be comes in the inversion. Okay. But in it means in a higher pair it is so much different. Okay. It means in higher pair if you fix one answer will come, and suppose if you fix other answer will come. Okay. For example, if I just place this kind of circle, you can see it's been a contact, it means only one point is there. So suppose if I just rotate it, it means this 1 2 3. So if I just rotate it, now it is 2 is there. So while we are just placing, you can see what this 1 is there, so 2 will come here. Okay. You can see here the point 1 will be there and here the 2 will be there. So while we are just seeing here, the entire thing has been shifted. Okay. So now each and everything will come a different answer. Okay. I think you got the one. So here the circle point and the straight line drawn are different, okay, contacting points are different, so shape will not be same, so they will be dissimilar, okay. I think so you got the point. So lower pair comes in the category of surface and area, and higher pair comes in the category of point area, okay. Degree of freedom is the number of independent coordinates required to specify its complete composition, okay. So next one, based on relative motion. The motion means, I think so it means just a movement based upon relative motion, how it's been acting, okay. So based on relative motion, you can say revolute pair, pin joint, turning point and hinge joint, okay. You can see revolute pair means just rotation, it means revolute pair, pin joint, turning point, turning joint and hinge joint, okay. It is a lower pair, okay. So next one you can see, it means in this thing one is being generally fixed and two will be just moving, okay. This comes as a category of turning pair, okay. So you can see relative motion is turning pair when we fix one side, okay. That's it, okay. So I think so you got the point. So next one is, suppose I'll just explain because as the video proceeds. So next one is again the degree of freedom. Oh, only we see the links, okay. It means transitional XY that we just see, rotational XY that we can. So the entire degree of freedom will be 3, okay. Suppose if we just take the degree of freedoms, it will be 3, okay. Movement is translation XYZ and rotation is also XYZ, okay. So degree of freedom will be 6. It means it can go anywhere. So degree of freedom is entirely link becomes connectivity pair, okay. So this will just explain. So you can see this is one link and this other box is other link. So we just interconnected. So it becomes as connectivity, okay. So connectivity is just a pair, okay. Degree of freedom is just link, okay. Connectivity is just a pair, okay. Degree of freedom we just see about the link, okay. So next one, chain is movability, mechanism is mobility, okay. That's it, okay. I think you got the point. So you can see A we can just rotate only in one direction, okay. One is fixed and A we can rotate in one direction, okay. I think so. So you can see the theta angle just varies each and every, so the theta is pair variable, okay. For pin joint the connectivity is just 1, okay. You can see for pin joint the connectivity here is just 1, okay. Just a basic thing, so no need to just confuse, okay, because as the video is just going on I just explain each and everything to you, okay. So you can just go to the next thing. Guys, literally this subject is one of the very much interesting subject you just want to have a look upon, okay, because we can learn lot of quality things in this subject, okay. So next we can just go. Before that, once again, I think so you are able to see this one. Okay, it will just move a little bit. Oh, it's okay. So the next one you can see generally turning pair, okay. You can see crankshaft in the bearing, it is called as turning pair, okay. So it means turning pair comes under pin joint, crankshaft in the body, while rotating on circles means axle and scissors holding on. So it's just a simple thing, guys. You can just take the scissor, it is called so the category of turning pair, okay. So connectivity means we fix one and we see other independent motion, okay. We just fix one side and we just see the other independent motion, okay. I think you got the point. So independent motion is pair variable, okay. So next one is called as sliding or prismatic pair, okay. Sliding means just a thing, okay. You can see this node is sliding over this area, so sliding or prismatic pair. So motion is just forward or backward, okay. Here comes sliding across also, okay, just sliding. So sliding is prismatic pair. In this entirely XY that only will be there, so won't be any kind of rotation, okay. So turning and sliding is always similar, okay. So turning, generally for turning connectivity is 1, okay. Connectivity is V1, okay, but sliding the connectivity is 1, okay. It can just move in X and Y axis, okay, that's it. So turning is generally lower pace definitely. turning is generally lower pair, and sliding is also considered lower pair. Okay, I think so you got the point. So next one is screw pair or helical pair. Suppose I think so you don't know about the screw. When we just rotate it, it becomes screw pair or helical pair. So in this you can see rotation and linear motion. So screw is generally fixed and nuts. Okay, so nut fixed and the screw rotation. Okay, so it means here the entire theta and it means the rotation as well as the movement in the acceleration is not dependent. Okay, it's not independent, they are dependent on each other. So okay, suppose if we just rotated 20 degrees, it will just go at acceleration according to 20 degree. Okay, so you can see connectivity, it should be independent. Okay, here theta and s are independent. Okay, so generally the connectivity should be independent, but since it is being dependent, so we need to just convert the independent into one. Okay, so we literally need only one rotating thing. Okay, I think so you got the point. So independent can't be two, it should be just only one. Okay, if I rotate 3 times, the screw is fixed bottom. Okay, that's it. Okay, so how we can just mention, you can see s equal to L theta divided by 360. So 360 rotates and screw goes and down distance. Okay, it is a pitch or lead. Okay, that's it. So s equal to L theta of 360, screw pair and helical pair. So lower pair connectivity 1, and so generally for lower pair connectivity is being only 1, theta or s. Okay, that's it. So if s equal to 0 means only rotation will be occurring. Okay, you can see yes, only rotation happens, it becomes a turning pair. If theta equal to 0, only sliding will be. Okay, if it's athletic, if lead is 0, the screw pair becomes turning pair. If theta equal to 0, the yes, it means if only the rotation will occur. So rotation means I think so it also comes under category of, it means rotation equal to 0 means what will be that the movement will be 0. Okay, so if the movement is 0, it is completely comes under category of sliding pair. Okay, so that's it. Okay, only motion, no rotation will be. So next one is, it means cylindrical pair. So in the cylindrical pair, rotation as well as the it means movement in acceleration will also be occur. Okay, you can see it means both of the things, here the connectivity is 2. Okay, because it can rotate as well as it can slide. Okay, but our thing, the connectivity should be 1. Okay, so we just stop one thing. Okay, so and simultaneously in the spiral thing, you can see it can be rotated in different axes. So x axis it can rotate, y axis also it can rotate, z axis also it can rotate, but it is a spiral pair, is a lower pair, it has 3 axes, 3 parallel, 3 connectivity. Okay, next one is, you can see planar pair and flat pair. You can see in this a movement in x and movement in y, and as well as rotation that also will be occurring. Okay, so 2 linear motion and rotation only one thing. Okay, forward backward. So if this moves up, pair will not be. Okay, so for this the connectivity independent motion is generally 3. Okay, so it means out of this entire 5 we will be only seeing about the planar thing. Okay, one thing will be turning pair and sliding pair. Okay, I think so you can understand. So not planar mechanism or screw and cylindrical pair. Okay, so planar mechanism we use only revolute and sliding pair. Next one is higher pair. So you can see in higher pair only, it means lubrication is easy in the lower pair, but in case of higher, it means in case of higher pair generally lubrication is not possible. Okay, so higher load cannot be in the lower pair. Okay, so when we get an option, we generally choose lower pair. Since guys literally lower pair is so much interesting thing that you just wanted to look upon. Okay, so you can see high load cannot be taken in the higher pair. Okay, generally. Okay, so next thing is higher pair. Okay, higher pair is just a point or line contact. Okay, that's it. So it means gear, ball, roller bearing, cams and wheels and each and everything comes under category of higher pair. In higher pair you can see, so lower pair you can see, it means this is, it means suppose this is a pin and this is just moving like this. Means for this we need to define x, y and theta. Okay, so to define this x, y and theta means we need 3 connectivity. Okay, so whenever you can see this can move here also, but if I fixed, it means only it can just rotate. Okay, so what I'm just doing, I'm just voluntarily cutting 2 motion x and y, I'm just fixing it. Now we will have only rotating motion. Okay, I think so, can understand. So another in this kind of things come the turning pair. So in sliding pair, you can see when a pair is connected by the pin, it means bottom and it means top and bottom is just restricted. So it cannot, the middle portion cannot has a tendency to go up and down. Okay, only it is just sliding motion only in the x direction. Okay, so when turning a sliding pair or used in panel, it arrests two motion. Okay, generally it means turning and sliding pair arrests two motions. Okay, arrest two motions and degree of freedom will be just one. Okay, it means only one axis, either x axis or either y axis, only one axis will just go on. Okay, so next one is higher pair. Okay, higher pair is generally so much riskier thing. Okay, it is often point changes to the rotation. Okay, so you can see in generally when one fixed on the sector is rotating, first it may be intersecting at a point, so some damage occurs, so we will not see. So motion among common axis, common normal is restricted in kind of higher pair. Okay, so next thing you can see only two variable will be x and y side. Okay, this one normal thing. So in this generally in higher pair comes under category of, it means higher pair will always have two connectivity. Okay, so in that arrested will be only one. Okay, you can see in the lower pair arrested is two but availability is only one, but in place of higher pair arrested is only one and availability is generally two. Okay, lower and higher pair only depends on surface and area of contact. Okay, lower and higher pair only depends on surface as well as the area of contact, not degree of freedom. Okay, so lower and higher pair degree depends on surface and area and point of contact, not degree of freedom. So generally degree of freedom will be related to the link. Okay, I think so, got the point. So actually you can see PT is not, you can see this way. So rotation also occur and movement is axis will also occur. Okay, so rolling pair I will just tell to you in later on video. No, later on video not tell. Okay, I'll just tell explain you now. Just 1 second. So you can just see the rolling. So it means one side of thing is, you can see, I'll just zoom a little bit. Zoom. So you can see in this entire thing, if the velocity is given in this direction, so it means, for example, this will just move like this. Okay, to be say in a particular motion, if I just had a coin, I don't know where. Okay, I'll just go with this one. Okay. So you can see this one. So this is a circle and the circle, it means it's going in this direction. Okay, so here each and every point will have same velocity like this. Okay, so next thing, the circle is will be rotating like this. Okay, so you can see this way here the velocity will be like this. Okay, I think so you're getting the point. So okay, the velocity will be like this. So the velocity will be dx divided by dt. Okay, so the first thing will be only translation, only sliding motion will be. So no portion, it means each and everything will be same, so no portion will just change. Okay, for example, this is A point, this is B point, means A point and B point just travel in a linear motion, that's it. Okay, suppose if this A point, this B point, it's rolling, means you can see, so now A point goes to in the top portion. Okay, instead of being here, it goes to here. Okay, B point instead of being here, it basically goes here. Okay, that's it. Okay, only rotation. Okay, no translation this. Okay, so it means omega equal to d theta by dt. Okay, it means angular velocity, rate of change of angle, that's it. Okay, I think so you got the point. So you can see now we add the both. Okay, while we are just adding the both, it will be rolling. Okay, rotation plus of translation will be goes to rolling. Okay, so you can see this one, this is entirely rotation, this is completely translation. So you can see now it's been rotating this. Okay, it is called as rolling motion. Okay, rolling motion. So whenever the velocity, it means translation velocity, the movement is linear greater than r of omega, you can see this one. So see this one I'll just explain in a better way in the fluid, means in the engineering mechanics, but I'll just explain. Okay, so velocity is greater than r of omega, so this translation velocity will be literally greater. Okay, so v equal to r of omega. Okay, so dx by d theta greater than r of d theta by dt. Okay, so x greater than r. Okay, so you can see in this for example, it's been rotating like, it means rotating like this means you can see it's been rotating as well as it's been transiting, so the independent variable will be 2. Okay, I think so about the point. Okay, the independent will be completely 2. Okay, so and as well as you can see if v, it means v less than r omega, here also the independent will be completely 2. Okay, but when you can see this one is v, this one is v, this one is v, and this one is v, it is been rotating. Okay, so whenever it means v is 10 meter per second, and when the translation was also 10 meter per second, you can see the translation will be 10 10 10. So you can see it is, this side is 10, this side is 10. So what will happen, it will become as fixed here. Okay, and it will just only rotate. It means the rotation will occur between like this. Okay, the entire thing will be rotated. So here what will be there, theta 1d will be there, so no linear sliding motion will be there. Okay, here the degree of freedom will be 1. Okay, so it becomes as higher pair. Okay, so you can see dx of d theta equal to r of d theta of dt. Okay, it is higher pair. Okay, degree of freedom is generally 1. Okay, okay, I think so, getting the point. So this thing I'll just explain in the other class. Okay, okay, so I think so you understood the class, and okay, then thank you, let me see you in the next classes. Until then, take care, bye bye, have a good day.